right, let's talk about titrations. First, make sure you watch this video of me performing the titration. It's only about 2.5 minutes long, and then you might want to watch it again after you go through these notes with me. So what's the whole point of performing a titration anyways? It's to determine the concentration of an unknown. Could be an unknown acid or an unknown base. So I'll write that out fully. To determine the concentration of an unknown acid or base. Let's talk about the equipment that you use in a titration. You have your mystery solution typically in your Erlenmeyer flask. Oftentimes it's an unknown acid. And then you've got your known base in the burette. And by known, I mean you know the formula, you know the concentration. And the indicator is phenolphthalein. This should definitely win a spelling bee. It's clear if the pH is 0 to 7, and it's pink if the pH is greater than 7. All right, pH underneath these. All right, let's label each of these as an acid, base, or neutral. So I'm going to highlight the basic hydroxides. So we've got 1, 2, 3, 4, and only 2 hydrogen ions. So the bases are winning. That is a basic solution. For the next one, we've got 1, 2, 3 hydroxides and 1, 2, 3 hydrogen ions. So this is neutral because they cancel each other out. And here we've got only 2 hydroxides and 4 hydrogen ions. So this one is an acid. So which of these would have a pH of 7? That would be beaker B, the neutral one. Which would have a pH less than 7? Beaker C. Which would have a pH greater than 7? Beaker A. Which one could be a soapy solution? Beaker A. Because bases or soaps are bases. Which one would taste sour? Beaker C, the acid. Which one would be slippery? Bases are slippery, like soap. And which one would be Diet Coke? Soda is acidic, so letter C. Then it says, using the picture from number 3, letter B, draw a new beaker showing what it would look like if a single molecule of NaOH was added. So let's see, I'll try and draw it kind of the same. We've got an equal number of hydrogen ions as we do hydroxide ions. And if we add an NaOH, we're going to have an Na plus and another OH minus. So now the OHs are going to outnumber the hydrogens. So this is now going to be a basic solution. It's no longer neutral. If phenolphthalein was present in beaker B, what color would it be before adding the NaOH? It would be clear. And then once it's slightly basic, then it will be pink. Okay, Brooke, one more snuggle. I'll be right there. All right, you lay down in your bed. Sorry, guys. Once the NaOH is added, the pH goes from neutral to basic. And then let's complete and balance this neutralization reaction. So HBr plus LiOH, we're going to make H2O, and we're going to make LiBr. That's the salt. And of course, we made water. It says, imagine this. Stupid Miss Baker left out some HBr without a label on it. To save her from getting fired, you decide to secretly stay after school and perform a titration to figure out the concentration of HBr, add a label to it, and save the day. You needed to add 5,000 milliliters of a 1 molar LiOH solution to 2,500 milliliters of HBr. So let's go through the steps. I'm going to pause this video and have you click on a second one so that I can say goodnight to my daughter.